And a quick review, finding the inverse of a matrix. All right, so this is a pattern that you've got to follow, and so I've got it up here on the screen. You can see the notation for inverse, of course, the -1, right? Because an inverse is 1 over something, or a -1 exponent. Okay, so there's a notation, and you've got to follow then this formula. All right, so notice the A and the D swap, right? The A and the D swap, and then the B and the C go the opposite. So meaning a negative times it, right? So the A and the D swap, and then the B and the C are opposite their values. All right, so let's see if we can apply that then to this matrix. So we want to find the inverse of matrix K. Now to do this, first off, I need the determinant. Because that's what the notation is right there, right? This notation right here means the determinant. Okay, so 2 times 4 is 8. Remember, going this way, negative, so negative and -3 is a +3. +3 times -2 is a -6. And the value of the determinant is 2. Okay, so now K to the -1, its inverse is 1 over 2, right? The K determinant. And then I got to multiply this. Remember, this is scalar multiplication. All right, first off, switch the 2 and the 4, right? 4 goes there, 2 goes there. And then remember, a minus 3, right? So that's going to make that a +3. And then a minus 2, and that's going to make that a +2. Okay, so now all I got to do is multiply. Hey, this isn't too hard if you understand the pattern. Okay, half times 4 is 2. I'm just distributing. 3 halves. 1. Almost put a 4 there. Oh, 3 halves, 1. And then again, a half times 2 is a 1. And there's our inverse matrix. 2, 3 halves, 1, 1. Okay, so how do you use this? How do you use this? Well, look here, I have a matrix equation, but I have a matrix times my variables. And so if I'm going to solve this, remember I taught you way back, quantities multiplied times a variable, you move by multiplying both sides by the reciprocal, which guess what is the exact same thing as the inverse. So this is K. Oops, hate when I do that. Sorry about that. Okay, so this is K, right? Right here is K. And so I need its inverse because I want to multiply both sides by 1 over K. That will remove it from this side and put it on the other side, right? Well, what is 1 over K? It's inverse. So look what I get. 2, 3 halves, 1, 1. And now I'm down to XY. Now I've got to do matrix multiplication. All right, across and down, right? Across and down. Let's see if we can do the across and down thing. Okay, so 2 times 4 is 8, plus 3 halves times 1 is 3 halves. That's the first element, right? And that's the top. The bottom's easy. 1 times 4 is 4, and 1 times 1 is 1. Okay, so the only thing to deal with here are these fractions. 3 halves, not a problem, and 16 halves. That's 19 halves. So let me go out here. Remember, we got XY. And so what do I get? I get that top value of 19 halves, and I get that bottom value of 5. Guess what the solution is? X equals 19 halves, and Y equals 5. See, we had to be able to multiply both sides by the reciprocal, which is the inverse of that matrix, and we're able to solve this matrix equation. I think that's awesome, and a little bit complicated, but once you learn the pattern, it's definitely doable, and it'll allow you to solve.